So Joel contacted Sean and myself, saying that he thinks we live on a heliocentric world and wants to have a respectful conversation about it. And I looked at your Facebook page. It looks like you're a big fan of the James Webb telescope.
Yep.
Okay. I've got a very interesting video coming out on that shortly.
Okay.
And where do you want to start?
Well, I mean, honestly, I got motivated to do this just a spur of the moment. I was seeing, I was watching a little bit of your podcast, and then I was also, I follow both sides a lot, but I also see, of course, the Simon Mandan stuff and Professor Dave stuff, and I hated how they treated you on that freaking video they did 3 months ago, just like making you a laughing stock. I'm like, that's not how to talk about any of this. Like,
because he's not a real professor. If he was a real professor, he'd have respect.
That's it. But yeah, it's just, I don't know. It's just, even if like, whether someone's right or wrong, that's not going to ever give you an excuse to, treat them like crap. So I was
when you don't have any evidence for what you're talking about, the only thing you can do is mock the other side and make funny faces and say, I don't understand when someone's trying to describe to you a perfectly simple concept that blows their argument away. One of the arguments I was trying to explain to him, if I'm looking north and the stars are coming from my right shoulder to my left shoulder, that's counterclockwise. Now, as I turn, they're coming up that wall and down that wall, up that wall. Now I'm facing south. They're coming from my left arm to my right arm. Now they're going clockwise. They never change directions, but he could not understand that.
Yeah.
So on a flat Earth,
you don't have to agree, but how do you not understand what he said?
I understand the point you were making, and he wasn't, and he was, even though he might have understood that point, he just cut you off and didn't let you make it, and just like totally disregarded it. So that's what I'm trying to.
That's a great thing. Thank you for noticing that. And a lot of people that would never have talked to me sent me messages saying, "Listen, I'm a globe earther, but I saw your, why did he act that way? I saw your interview that YouTube is pushing, right?" Mm-hmm. Dave has 2 million subs. How many of them showed up in that live chat? He should have had 20,000 or more.
Yep.
Zero showed up.
I unsubscribed from him because he got way too like just facetious and disrespectful.
Well, that's all he has. That's all he has.
People. So I don't know. Today, like, when I'm making my points and stuff, I might be using some tools that, I understand there's an issue with authority here. That's probably one of the main issues, is an issue of authority, of who we're trusting, the sources that we're trusting. Obviously, you guys don't trust NASA. No, I don't.
I mean, if they put out something that was real, we might trust them.
Sure. Yeah. So anyway, we're dealing with issues of authority and understanding of concepts, I think is where things are coming from.
Joel, I'm going to let you talk as much as you want. I may interrupt because sometimes I get very excited. Fine. Tell me to shut up if I interrupt too much. Do you believe that image behind you is a real photograph or an artist rendition?
Well, that's one of my things, right? I'm a star nut. A lot of my friends are astrophotographers. I'm involved with the Miami Astronomical Society out here in Ohio. And this image was actually taken by a friend of mine. So this wasn't from like NASA or website or anything. And I was actually there's a couple other things I'd like to show you. This is, again, using sources that I purport that you probably wouldn't trust anyway, but to see if it can help explain things with how I understand it. So maybe you could see how I'm making sense of these things.
Sure.
I'm a big math nerd too. So I think the strongest, the things that I've relied on the most isn't what I've been told growing up, because I mean I was homeschooled, so pretty much everything I had to like deconstruct from that. But I'm a believer. I'm a Christian. I believe there's more than just the physical realm. But I'm also very much into science. I love math. I think math is beautiful. It's a language that describes mechanics of the well, I believe the universe. And I think my biggest contention that I find just sad for me is the flat Earth model just it disallows the appreciation for the cosmos. Like it's just I've seen so much of not just pictures, not just videos and stuff like that, but with my own eyes. I have this pretty sizable binoculars. I'm getting newer ones with like 100 millimeter objective lenses, huge. A lot of light can come into these things, and you can see. Just the other night, I was out with friends of mine, 9.5 inch diameter telescope, huge thing, and I was looking at Triangulum Galaxy, Pinwheel Galaxy. I was looking at different nebulae. I was looking at the Ring Nebula. I was looking at all the Saturn, Jupiter, Andromeda Galaxy. This one behind me. I was looking at that with my own eyes.
So I'm not denying that you're looking at it with your own eyes. The question is, what is it? How far away is it? And that's something that you don't know other than what other scientists have told you. And
Sure.
We could actually prove that these things aren't that distance away. So you're a big NASA follower. Do you know that they tell us Polaris is 433 light years away, but I think they're trying to change it to say it's 100 light years closer. Have you heard that?
I have not. No, I haven't.
Okay, so that's something they're debating 100 light years closer. That's a problem. But even if it was 100 light years closer, let's think about this, right? How far away is our sun? Do you know?
93 million miles.
About 8 light minutes. That translates in. Okay.
Sure.
So if the sun was a mile over your head at 12 noon and you went outside and looked up at the sky, what would you say?
Well, what size is the sun?
The size that they tell us. The sun is a yoga ball and we're on a BB.
Okay? Yeah. I mean, you're not going to see anything.
You're going to see anything. It's going to fill the whole sky, horizon to horizon.
Right.
We're in agreement. We move it 8 light minutes away. It's now the size of a coin held at arm's length, right? Just like we see the sun.
About, yeah. Well, it's a little exaggerated too because of the atmosphere. But
okay. Yeah. So if I doubled the distance, that's double the distance. How much smaller would it get?
Well, so that's where you get into like the inverse square law of light travel.
I'm not even talking about the brightness. I'm talking about the angular size because the brightness, that's a whole nother issue, right? Double the distance, it's going to get somewhat smaller. Some people say you couldn't see it. Some people say it would be half that size. I believe you can't see it, but let's just go farther. If we doubled that again, so now it's 4 times farther, that's a light half hour. How much smaller would it get? If we doubled that again, so it's 8 times farther, that's a light hour. Mm-hmm. It is scientifically provable that the angular size of the sun, forgetting the brightness issue, is too small for your eye to resolve. Okay? Well, the sun isn't 8 times as far, so we can see it. But they tell us Polaris is 46 to 48 times bigger. So an equal distance would be 48 times 1 light hour, which is 8 times as far as the sun, and that would be 2 light days away. It's scientifically provable that we could not see Polaris at 2 light days away. You like math? Let the math sink in. And they tell us it's 433 light years away. Well, you got to take that 2 days, times it by 180 or whatever, and then multiply that times 433. Okay? These are impossible distances. So right there, when you actually do the math, write it down, look what I'm talking about, and understand Polaris isn't what they say. Therefore, everything else you're seeing is a lie. Everything else you're seeing is misinterpreted. I mean, have you seen this James Webb image? I mean, this is...
Yes. Yeah, I've seen that one.
You've seen this one. How about this one? Have you seen this one?
Well, aren't these all just from their basically their log of all their calibration images?
No, I made these on a little app on my phone. It took me 2.5 minutes. Okay.
Oh, okay. Well,
so what I'm saying is my pictures look better than James Webb. Here is hold on. This is my friend Jenny. She let me just show you. This is a little app she has, and I actually did the same thing. And I'll just fast forward through this. Bam, 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 and she created this image It looks as good as anything James Webb put out there.
And how much does NASA make every day to do this?
Yeah, 63 million dollars a day. I did this with a free app. Actually, the app costs like $30, but it's a 14-day free trial. So I think NASA can get the 14-day free trial, make as many pictures as they want, cancel the subscription, and not cost us a penny to make the same things that people will swear are true. If James Webb released this image, you would swear it's true.
Yep.
Okay. Well, let me see if I could show you guys something. I'm curious about your thoughts on this.
Hey, wait, one more thing. I like you, Joel.
Oh, thank you.
we totally disagree on where we stand, but we're having a conversation, and it's okay to change your mind based on new information. But and the one comment you made that I want to address by the end is that by the flat Earth argument, this what'd you say? It takes away from the amazingness of this expansive universe. Our view of the world is more amazing than an expansive universe. And once you understand what that is, it's way more amazing, and it's within our reach. All right, go ahead. Sorry.
Good point.
Am I able to share my screen?
Yeah, hold on. Let me set that up. Sorry about that.
Thank you.
No, you cannot share your screen.
Okay.
Go for it. You're good.
Okay. Let's see here. I'm curious your thoughts on this image here. If you've ever seen it. This is a popular stellar object called the Orion Nebula. I have seen this one with not this much detail. Obviously, it's a long exposure shot. But I'm curious I'm just curious what your thoughts would be on something like this.
Sean, you want to go first?
Yeah, but thoughts in what? You mean what do I think I'm looking at by?
Yeah, we could go with that. Yeah.
Yeah. I mean, it looks like a lot of Photoshop involved in terms of enhancing things. Anyone could take a picture of the sky, get the exposure right, and then go into Photoshop and start messing around. I would need to know the source of this photo first.
So this is the same. A friend of mine. I've been out with him during the nights when he has his long exposure tracking and everything on. He took this image. He's an astrophotographer.
Okay. So what do you think it is? We should have heard that first.
So I'm pretty sure Orion Nebula is an emission nebula. So it's a massive, massive thing here that we're looking at. I don't know how far it is, but I'm just curious, when you know people, I encourage you guys to talk to people in astrophotography. So the source isn't from, NASA or, the mainstream space guys, but there's people like me who are getting into it. You could just get a normal DSLR camera with a wide angle lens or with a little bit of magnification. You can't get something like this. You'd need a significant telescope for this, but his other stuff here, like shots like the Milky Way. This is the Dumbbell Nebula. I was looking at this the other night. You can see it. It's obvious. It doesn't have as much color when you look at it, but you can see the faint green fuzz of it, I suppose you could call it. These are the Pleiades. Again, these are all his images. I've been out here when he takes images.
You keep saying images, my brother. Do you mean photographs? Because those are two different things.
Okay.
That's why I'm asking. I'm not sure. You keep saying images. That means that it was something was altered.
Right. It's photographs. Yes. What happens is you take a bunch of photographs at certain exposures, say about 15-20 seconds each, and then you stack all those images on top of each other, those photographs on top of each other, and then you get the full, all of those photons have been striking the camera sensor, and then you get the full picture of it, because our eyes aren't seeing 10 seconds of exposure 30 times in a row.
Yeah, and I love photographs and even images of the sky. It's always beautiful. I don't know what that has to do with where we live, what we're standing on, but
so this is Australia's sky right now. For example, my fiance is in Australia, so we have an interesting I guess, relationship with the shape of the Earth, if you will. It's very
Yeah.
cool to watch. Whether it's whatever model you believe, either the sun's coming up on her side, or it's moving over to her side. However you want to describe it, it's still cool to see it happen on like chat, like in real time. It's very interesting. And so this is her sky. Here's the Orion Nebula right here. It's that same thing. It's right here. And I have seen this with my eyes. It's a lot dimmer than this, but you can still see.
So what do you think that is?
So it's an emission. I think it's an emission nebula. So this region of space that's full of gas. That's
But let's pretend like the indoctrination camps didn't, and the space magazines didn't teach you all of this information of what these things in the sky are. What if you just walked outside right now with no basic recollective information of what any of these lights are? You know it's beautiful, but you're like, I don't know what any of this is. And then you saw this. What would you think it was if you were never told any stories or given any names or any because they've attacked your brain for so long with this stuff, it becomes like it's permanent to you. That's what it is, but that's something someone created. That's something that someone made up and presented it to you. And this is what it's called. And then they go into the real deep CGI images of this shit when they're trying to pretend like they're going to expand it for you. And they're like, that's all composite. But they're like, hey, I just want to know, like, do you understand what I'm trying to say though? Like,
well, right. Yeah. So you're talking about if I was just out there personally subtracting, whitewashing everything else that that we purport to know about space,
yep,
what I would think these certain things are.
Yeah.
I mean, I'm not sure what I would think. That's why, and that's why we've had guys through history probably asking the same thing. That's kind of like how science starts, is like we're asking, what are these things? How is this stuff working? And we've had a long string of people asking these questions.
You see the image I'm showing right now?
Yes.
Is this a NASA image, or is it something that I made while you were talking in the last 2 minutes?
I don't know.
Okay, good answer. Good answer.
Yeah.
But if NASA told you this was the CSMAX Nebula 4205 in the so-and-so region of space, you would believe it.
Well,
you probably would, though. You probably would.
I probably would.
Yes,
I probably would.
What is the difference between this image and what you just showed me? I think mine's better. I think mine's more believable.
Well, what I showed you, I have seen without.
No problem. I'm not going to deny that. You can see things that look like this in space, right? But how far is that? Are you seeing 10 miles, 50 miles? Are you seeing a smudge on the firmament or lights in the firmament? We don't know what it is. But as I proved to you using the math that you love, that you can't see Polaris at 2 light days away, but we can still see it at 433 light years away. Ridiculous. And then add the inverse square law to that, you got a huge problem. Okay. I don't even throw that in. At 2 light days away, the inverse square law says that the light would be so dim that you couldn't see it. But 433 light years away, we can see it bright in the sky. We can see Saturn, Jupiter, Mars reflecting sunlight off of their non-reflective surfaces with a distant sun that's smaller than a coin held at arm's length. That light is bouncing off of that gassy or dirty planet and coming back to Earth, ignoring the inverse square law light, and is brighter than any star out there. You're not thinking.
The official narrative of everything, Joel, has been destroyed. I understand where you're coming from in terms of like, I see these cool things in the sky. I'm looking like, so what your brain's doing to you is saying it's coming up with that word already, the nebula or the this or these space words that we grew up with, and other people, adults, are still about it and showing it and teaching classes about it. All three of us can create a class and, with information. It could be false information, and we could teach our students this for centuries. But the information they're teaching is false. Doesn't matter. You can get an A on your test and feel good about your exam on all this stuff, but it's based off of lies, is what we're saying. So when you actually look up in the sky and see these lights in the sky, that's all we know, Joel. They're lights in the sky. We can't touch them. We can't get there. But you know what? When modern day optics now, the P900, P1000 cameras are zooming in on these, we're not seeing what you see. Apparently we all have different camcorders. Flat earthers have camcorders when we're zooming in with the optics that are able to let you zoom in that far. So if I could zoom in on a hotel 80 miles away and see a window, boom, I'm maxed out zoom. I can't go anymore. I'll go in more. I can't. I'm maxed out. It's a great camera, but it only goes that far. And then I do the same thing going up, Joel. Those dots in the sky that you're praising are, probably trillions of light years away. Those dots in the sky would remain dots in the sky as I'm zooming in with the camcorder, man. This Nikon 1000, I zoom in, those little dots as I'm zooming on the sky should remain that size, but they're growing in size, and you can start seeing details on where these things are. I know Dave has a lot of video clips on some. Yeah, some of them are out of focus and some of them are in focus, but it's the point. Use your common sense here. Those little dots in the sky remain that size as you're zooming. They're so far away, but they're growing in size and clarity as you're looking in. Dude, that's not that far away at all. That would never be able to happen. Whether it's out of focus or not, that can't happen. You just got to use your common sense here. But I want to hear what you'd say about that.
Okay, so two things. First, I wanted to address the star distance thing. Because originally I want to make it kind of clear. I agreed with you that the angular size, or whatever you want to call it, of the sun gets smaller and smaller. But you said something very key there that I willingly went along with.
Go ahead.
To go with the point, you said, regardless of the brightness, we're not talking about the brightness. If you're just talking about the size of something, yes, it will get smaller and smaller and smaller, where you technically wouldn't be able to see it anymore. But you very specifically said not the brightness. We're disregarding the brightness.
Yeah, because that would destroy it even more. He was trying to be nice.
Right.
Well, no, because the brightness of the stars and the brightness of what we're seeing out here. First of all, they're very close to us in proximity of the spans of the galaxy. We're talking about a tiny little piece of the galaxy that we're looking at.
Are you, Joel? Are you saying that they're much brighter than we're thinking, and that's why we can see them?
We could actually the magnitude of stars is a big part in how we measure how far away they are.
So the brightness. So a simple example for you can do: you get a small box, and hold a little LED light in it, and then measure the brightness on the wall of the box. Then put that same LED light into a bigger box, maybe 2 feet wide, and measure the brightness on the wall, and it's magnitudes less. And then go into a dark room. You have a full-size room and hold that LED light and see how much light you get off the wall. You can't, because that light is spreading out, getting thinner and thinner and thinner. Light doesn't travel in focus points for billions and billions and trillions of miles for millions of years. That's a nonsensical, unsupported belief that has nothing to back it. So you cannot see Polaris at the size that they tell us at 2 light days away. The other thing is the brightness issue. The moon, if we say it's 1 lumen, it's about 1 lumen. Maybe it's more, but let's start with 1 lumen on a full moon night. 1 lumen. Halfway to the moon, it's 4 lumens. Halfway again, 16. Halfway again, 64. When you get to 100 miles from the moon, where the astronauts took that famous picture, the moon would have to be 64 times brighter than we see the sun from Earth for us to see it at 1 lumen, following the inverse square law. Okay, this is all complete and total unsupported pseudoscience nonsense.
It's a story. You could believe it or you can dissect it. There's nothing else.
Right.
It's not even not believing it. It's you have to dissect what they told you. Little by little by little, it starts unraveling, and you're like, they lie about everything. They just lie about everything. That's it.
So
I mean,
there was a couple mathematical errors. It's not just the inverse square law that we're talking about. That's a big part of it, of course, but there's a lot more factors to factor in when you're talking about an analogy of a light in a room, as opposed to at least what I would consider a large fusion nuclear reaction that's happening, and basically a consistent explosion that's constantly going on. So that's going to give off a lot more electromagnetic energy, way more lights and photons and radiation than any like LED light or anything like that. So that was going to be my point with the brightness.
A scale model. All right, go ahead.
Okay, you were talking about the camera zoom. I just blanked on your name.
Sean.
Hibbeler.
Yeah.
Okay. You were talking about the camera zoom, right? An important thing about cameras that we need to understand, if we're trying to apply common sense, when you learn about optics, when you learn about how lenses and sensors take light in and then record it into a photograph, a camera, even with a P, whatever the model is, that can zoom in super, super far, the reason that you're getting those things is not just because it's out of focus. It's not just because atmospheric disturbance or whatever, even though those could be other reasons. The reason is because of the aperture of the lens. It's not able to get enough photons in it because it's so small. So if you were to take maybe the same camera or like just any other DSLR and attach it to a telescope and do the same thing, you're going to get a better, more distinct result of what you're looking at because
Dave, do you agree with that? You're going to get a better result than a P1000?
I don't agree with that, but again, I had access to an observatory all through college, used it, and we're seeing nothing that when I saw Saturn, I'm like, oh, there's Saturn, right? It's a light. It's not the distances that they're telling us. And I used that what. A lot of times we use the telescope to zoom into the girls' dormitories across campus, okay? And it could only go so far. But then all of a sudden I can see, deep into space, millions and millions of miles. I'm not buying it. Not buying it at all.
And I'm saying the same thing with the P1000. And that thing's a great piece of technology, and it goes extremely far, and you can see extremely clear, detailed stuff on ground, I'm saying. And of course, We're looking through way more opaque, just funk everywhere in the distance. But the point is that we're looking up with less of that, but I'm just trying to figure out how those dots in the sky are growing in size as we're zooming in. If they're so far away that our own eyes, we're looking at it, that's trillions of miles away. Well, that should remain that way. Or if you're just distorting it and making it bigger, it would just completely blur. I've seen videos of them zooming in on these lights in the sky. They all look different. They all have their own colors, their own little shapes and weird. It looks like something like a frequency vibration.
Sure.
With water, and you could reproduce this in your own kitchen. You take a bowl of water or something, glass, something see-through, and turn all the lights off and put a bright LED light underneath. You'll look at your ceiling. You'll see the same thing that we're seeing when we zoom in. This on Dave's screen. You'll see that effect and other effects like these other stars that we've zoomed in on. And you will be able to see the same thing.
You can see this with your naked eye.
That's real science to me.
You can see this with your naked eye.
Exactly. That too. Yeah.
So I'm trying to draw a diagram.
Yeah, but think about what Dave just said. If you look, you can see the naked eye is the upper right thumbnail. You could see that with your naked eye. You zoom in, it gets bigger. You see a little more detail. How can we see these things with our naked eye at the distances they are? I know they sold you on because they're just things. It's like, no, man. If you actually look up in the sky, most things are the same size. But they're supposed to be trillions of miles farther apart from one another.
And that light is spreading out. Lasers even spread out. Okay? Right? So when it spreads out, what is it? Multiplying its brightness? Light doesn't travel for thousands of miles, let alone billions of light years.
So this is what's going on. So let's say we have, it's not going to come up. So you have so this is like a camera, lens, right? Or, it'd be bigger than this, but it's just it's a small in comparison to a telescope, for example, a mirror, a big lens. You have something like this, and you're taking something this small that can only take in this much amount of light and zooming in by, I don't know how much these cameras can zoom in, but they're zooming in a crap ton, only seeing the amount of light that this little lens can take in, as opposed to a telescope that
taking in more light.
If you zoom in, yeah, it takes in more light, so it can handle.
Let me ask you a question.
A lot more.
If you so before even now, but they use large telescopes on Earth that are out south, and they've taken like that deep field image, a famous image that showed. They said they were focusing on a piece of the sky the size of a grain of rice, and they did a long exposure, and they saw hundreds and hundreds of galaxies that have hundreds of billions of stars. Okay,
sure,
and they said that now these giant telescopes are put on cement pads that are like 5 feet thick, right? And so so there's no vibration. And they said that they do a long exposure where it tracks that field.
I need to provide a correction there. This is the deep field images were by the Hubble.
They were by the Hubble? Well, there was so it wasn't the deep field one. It was one that was on Earth. But they said that the guy, the technician had to wear socks and walk carefully so not to send any vibrations through the image. So hold on.
You're good. You could keep explaining. I was just going to pull up this one constellation that is one of my favorite constellations. It's called Coma Berenices, because it's one of my favorite constellations because of this cluster here. Again, my friend has gotten photographs of and stuff like that. All of these, at least from our what you would see is not common knowledge. These are all galaxies, okay? Because they're different from stars. You could tell a star. This would be a star here, and the galaxies here are more like fuzzy. Actually, in the same constellation, I was just looking at this galaxy here called the Needle Galaxy. It's the Edge-on Galaxy. So you start to learn your way around.
Have you ever seen that Edge-on Galaxy with your own telescope, or are you just looking at it in a computer simulation program?
No, I was looking at it with a telescope. Yeah, I saw it. You can have the telescope point at it, and
you say you like math, but you like to ignore math because math says that we can't see these things at these distances because of the size and the brightness. You want to ignore that. And I'm not going to allow that.
Well,
right. So let me get back to making my point. Okay. The long exposure photographs from Earth track with the rotation of the Earth to stay on that spot in the sky. No vibrations. The problem that I have with that is, are they forgetting that the Earth is orbiting at 66,000 miles an hour and chasing the sun at 500,000 miles an hour? And if you want to say the Hubble telescope did it, okay, how is the Hubble telescope falling around the Earth at over 17,000 miles an hour and focusing on a point in the sky and chasing the sun at 500,000 miles per hour, but still focusing on a grain of rice size, piece of the sky for hours and hours and hours? Okay, this is a fantasy that you just believe, but it's absolute nonsense.
So, well, there's a couple points there, but I think the biggest thing, since if we want to talk about math, I think it's a good, robust thing that we can all reference. We could all work out for ourselves, which the biggest thing with looking at distant objects is, again, going to be the magnitude of the brightness. Now, when I saw that Needle Galaxy, it was super, 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 super faint. So it was about like this. But
they love faint things. When us in the world can go outside and see faint things, NASA, they all love that shit. They love it because they're like, oh, let's enhance it to be this fantasy that you could defend, because you're not going to give it up if you like this type of stuff until you know what it is.
I'm not talking about NASA though. Okay,
I understand. I'm just making a point.
The only time I'm going to reference NASA would be when I show you, if we're able to. And I'm okay with going longer than an hour if you guys are. I'm just going to put that out there. I know you guys stick to a schedule and everything, and I can respect your time, but I'm fine with going however long the discussion allows for. Sure. But the only time, I was just going to say, the only time I reference something from NASA is NASA's Eyes, which is a software that I think can help explain my perspective on why these things work, specifically orbital mechanics. And I wanted to address the numbers that we're talking about here with orbital speed, rotational velocity, angular velocity, all of this kind of stuff. I think that's where the biggest misunderstanding is, and I understand the misunderstanding. I understand why it sounds counterintuitive when you initially ask the question.
Wait, but back up. Why wouldn't you want to resource NASA? That's the space agency it's like the number one space agency in the world of heliocentrism. Why would you not want to be like, look what NASA said? Why you don't trust them?
Because I was gonna try to show you guys how it lined up with.
No, but I'm asking you, do you not trust them, or you do trust NASA?
No, I do
trust
them.
Let's use them then.
Sure, and I was just saying, for the case of the discussion, I'm not going to fully rely on them because I know that they're not a trusted authority by you guys. So you're not going to accept as much.
Joel, let me ask you a question. Okay. Joel, let me ask you a question. If I could show you that NASA is faking crap, can we rule them out for anything else that they show you? Can we just wipe out everything? Like, if I can show you them lying, faking space.
If I were to be fully honest, I don't know if I could say that. Because
but why?
What do you mean? If they're caught in a lie once, if you see with your own eyes that they're lying and they've lied to you, and we can prove that based off of not what we did, what they've done, the stuff they've actually released, and we've
still going to believe it. Are you one of the guys? You believe we went to the moon, right? If one of the astronauts that went to the moon got on a press conference and said out of nowhere, he goes, "We faked it. We never went to the moon. It was filmed in a studio. We did it against our will. Whatever." You'd probably still believe we went to the moon, right?
I gotta say, I'd like to deviate from the moon thing. I think
let's soon get out of the sky and get down to the earth with the things that we actually
I'm waiting to talk about the Earth.
Sure,
you guys want to look at pretty lights in the sky.
I just it's a big part of why I have accepted the heliocentric.
I get it, but pretty lights in the sky, brother, does not prove your lack of curvature. There is none. So
okay, well, let's talk about the speed thing. Okay, okay, let's talk about the speed thing. I think because that's one of the bigger misunderstandings that I think I can at least try to speak to. Okay, the speed thing, the 100 miles per hour thing, the 67,000 miles.
66.6. So 66,000. Always remember 666 with NASA. You should always remember that. 66,600.
Okay. Yeah. Well,
not 66.5 or 66.4 or 66.291 or a random speed. 666. Just so you know, because you're Christian. I just wanted to remind you. But go ahead.
Okay. Well, so you guys were asking how. I guess one of the biggest questions. Do you guys agree with the question? How are we spinning at 1,000 miles per hour and not feeling like diddly squat?
Sure.
Is that an agreeable, fair question that you guys are curious about?
I think I asked that to myself in like maybe 5th grade. But
okay, sure.
Nowadays, it makes more sense that we're just not moving. So, yeah.
It's a reasonable question.
Yep.
And I'm curious of your guys' reactions on the answers that could be given through physics, through mathematics. Okay, he's showing okay, I'm kind of glad you're showing the clip.
Yeah, me too.
This is where I'm going to pull the NASA thing in. So we have this, because you're showing that, and that's not what I believe, by the way.
Well, that's what mainstream tells us is happening. You can't pick your battles with the lies, man.
This is what's happening. This is live, or not live footage, but live tracking of what this actually would look like. Okay, so we could go here. Where's Earth?
You're in a video game,
Oh, it's a simulation, but
a video game.
You could line this. I've used this to line up to look at the stars before. So here we have all the satellites and everything. I kind of don't want any of that. Yes, it's a video game, but it's tracking in real time. Okay, so if you were to, for example, look at where the planets are located,
all on a flat plane.
Okay, sure, but
above the
over
Earth.
In this direction, we have back here we got Mars, Uranus, Jupiter, Neptune, and I was just looking at Neptune and Jupiter and Saturn in the same spot in the sky. Okay, but this is the speed at which this model purports that we're moving in. Okay, so on this scale of what we're talking about, this is how fast the Earth is rotating. Okay, so it's not like that video that you're showing there. I think that did a horrible disservice to anybody who believes the Earth is a globe.
All right,
This is what it
so
actually
you're
would
saying
look
this
like.
this is what it would look like at that scale. But have you ever been on a merry-go-round? A merry-go-round with the horses? Of course you have, right? As a
Yes,
child.
yes,
Okay, so
yes.
imagine you're on a merry-go-round that spins around once every 24 hours. You wouldn't even know it's moving, right?
Right.
It would be hard to tell that it's moving. Now let's
Right.
expand that merry-go-round out to 24 miles in circumference. Well, now you're
Okay.
moving at a mile per hour. Not bad. There's really not much outward force. Now let's span it to 2,400 miles per hour. Now it's going 100 miles per hour. You're on that outside
2,400
horse,
miles.
2,400 miles, 2,400 miles. You're going 100 miles an hour in a curved trajectory. Okay. You're curving at 100 miles per hour in a big
Hmm.
ass circle. Now expand it to
Sure.
24,000 miles an hour. You're going faster than the speed of sound in a curved trajectory. And any
Sure.
change in trajectory, you will feel as acceleration. Okay?
Hmm.
So don't tell me,
With you
and
so far.
it's been proven that if you spin a disc at that size, at that speed, it will explode. Right? The angular velocity, the stresses are proven that nothing can hold up to that, right? So you believe and that's the slowest speed. Here's some. This is what you believe, okay? You believe that we are orbiting the sun 10 times faster than this hypersonic sled. Ready? Watch it. Gone. Can't even see it. We're orbiting the sun in a curved path, not a straight line, 10 times faster. And we're chasing the sun in a curved path 100 times faster than that. Okay? You can't even fathom it. But when you go out into nature, we can see water that tells us the earth isn't moving. The container of this lake is not moving.
Hmm.
Any
Yeah.
movement, you'll get a plate of water in a car going any speed you want and have that car take a turn. That water is going to be right out of the plate.
Sure. Okay.
Okay?
So here's where the misunderstanding is. I'm pretty sure I caught it. Um, the concept, of course, and you guys have probably heard this before, but I'm not. I think this is where the misunderstanding comes from. Is speed is relative. Okay. So that rail, whatever that was, going like that right past you, that was relative to the ground, right? Okay, so now let's take the merry-go-round example again. Let's say it's the size of the Sahara Desert. Okay, big old merry-go-round. You're sitting at the edge of it, and it's spinning one revolution every single day. Okay, so that's 1 degree. I'm not doing the math properly in
One
my
per
head right now,
day.
but it's still very slow. Okay, very slow. If you were to be closer to it, you're just going around one time. So you're still going to be doing that at the edge of this merry-go-round, right? The radius. This is the center. You're over here. It's spinning around once every single day. But relative to the ground, you're going to be flying across the ground like super quickly. So you're going to be seeing the ground passing you super, super fast. But you're in relation to the merry-go-round that you're on, you're still spinning at 1 revolution per day. Okay, so you're still not going to feel. Let's say you were like in a room or encased where you couldn't see the outside world. You're not going to be feeling this outside force
How
because
about
it's
if you were
still
free falling at the speed of a skydiver without a parachute?
okay.
Because
But again, that's because he's relative to the air around him. Okay, so that's slightly different. It is a difference. Okay, because speed is relative. So imagine two astronauts in space, right? There's nothing else.
well,
It's
you'd
just two
have to
astronauts.
imagine that. Go ahead.
Okay, all right.
You got any footage of that? I'd like to see
Yeah.
that.
Okay, so you have one astronaut. Let's say you're one of the astronauts, and your friend is coming at you, and you pass each other, right? Now you have to ask the question: which one is moving? Okay, which one's So how would you answer that? I'm curious.
Depends on which green screen guy is operating
No,
which camera.
okay.
Which camera?
No astronaut.
ahead.
Okay, you're just floating in space. How would you answer which one is moving past the other one?
Space doesn't. We don't believe space exists. So you're asking a question about Narnia.
Yeah, prove how fast Santa rides his sleigh, bro.
Okay, well,
right.
It's a hypothetical. It's a hypothetical to make.
Well, then there's no right answer.
Everything you're talking about is a hypothetical. If that galaxy behind you was X distance away, could we see it? The answer is no. But somehow you still haven't addressed how we can see Polaris. How can we see Polaris?
The magnitude of brightness. But
but you haven't done the math. The magnitude of brightness is, can you imagine the sun 64 times brighter than we see it? You can't even imagine it twice the brightness because you've never seen anything that bright. But you're imagining Polaris is 100 quadrillion billion trillion times brighter than the sun in order for us to see it.
Not necessarily.
Not necessarily.
Let's go back. Let's go back to because we need not necessarily because let's go back to just stick to the speed question.
Just because,
right? Yeah. No. I can answer that. I'm fully willing to work out the math on that with you guys. I will.
I've done the math. You can. We don't. You know. You can do the math after we're done here. I'd rather let's talk about where's the curvature of your 24,901 mile around ball.
Okay, but first we haven't finished the speed question, okay? Because we need to learn how to define speed, okay? What would be your guys' definition of speed?
A relative to a point somewhere else, a non-moving point.
Yeah.
So let me just ask you a question. I'm going to help you get through this. NASA says that we're moving 66,000 miles around the sun.
600.
Yeah. Don't forget that. And chasing the sun at 500,000 miles per hour. What if NASA told you that we're going around the sun at 500 million miles per hour and we're chasing the sun at 1 trillion miles per hour? Would you use the same argument that you're using now?
Well, probably not because
why not? What if they said it?
These are mathematically rigorous values, and that's what.
Wait! Mathematically rigorous. The speed of our orbit and the speed of the sun is mathematically rigorous. Who came up with it? Because every test has proven that we're not moving.
Originally.
No, you're absolutely wrong, and even your scientists will say that it's unprovable. Excuse me. For example. Do you know who George F.R. Ellis is? He's a well-known physicist. His exact quote is, "I can construct for you a spherically symmetrical universe with the Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds." In my view, there's absolutely nothing wrong with that. What I want to bring to the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that. Okay, you're using philosophical things that you want to agree on, but you can't prove that we're not at the center. You can't prove how far these things are. Nobody knows how big or far the sun is, right? And the way that they came up with it is absolute insanity. It's absolute insanity.
They've never proven how far the sun was. They also have changed the distances many, many times over the years. At some point, it was 1 million miles away, and then it also got up to over 110 million miles away, I believe, and they brought it back to 93. It's like, come on. First of all, they can't prove how they came up with that, but they keep changing it like it's nothing. That's why he's saying, what if tomorrow they go, hey, by the way, the sun's now 152 million miles away? You're just gonna be like, oh, okay. Well, what do you mean, okay?
That specific issue would be because the Earth isn't in a perfect circular orbit. It's an elliptical orbit, slightly, by a little bit.
I don't understand what you're saying. So you're saying it went from 1 million miles away to 60, I think was the next one, like this, and it was because of something that's happening above us?
I'm not sure that's necessarily accurate. I mean, I haven't heard the what you're talking about, but there is a difference in the distance between the Earth and the sun because here's the sun, Earth is going around it. It's not a perfect circle around the sun. It's sort of
Right.
like
It's speeding up and slowing down. It's speeding up and
Yeah.
slowing down.
only by a little bit. Okay, it's
Okay.
not by
So-
a super big amount.
Can we pivot? We can stay in space for a little bit. I want to ask you about gravity. Are you familiar with the three-body problem? I can explain it if you're not. I can explain
go ahead
it.
and have it explained.
So the three-body problem is this. In a computer model, best computers in the world, you could say, all right, I got a sun, it's this big, it's got this much gravity, and I've got a planet, and they can calculate where it's going to be, the orbit it's going to make, and they could be extremely accurate. Then you add a third body to it, like a moon or another planet, and the entire thing goes into complete and total chaos mode where they can only figure out what it's going to do for a short distance, right? So this it's pretty ordered right now, but then all of a sudden, just three bodies, and it goes into absolute insanity chaos mode, and no computer can figure out what it's going to do next. Well, how is it that we have a solar system with 8 or 9 planets, tons of moons, asteroids, comets and stuff that always follow an exact path? How is it possible in this beehive crazy gravitationally run solar system galaxy that we have eclipses in patterns that repeat themselves every 18 years like clockwork? How is that possible?
I guess the one word answer of that would be mass.
Mass, that's a word. That's not an answer. It's a word.
Okay, so the full answer is because, I mean, at least in that simulation you sort of showed, it looks like those are talking about the same mass of objects. Like those
no, it doesn't matter. Big mass,
points.
Little mass, all the same masses.
Well,
three bodies together going in orbits.
Okay.
They will go into random chaos mode, and science can't figure it out.
Well, okay, no. Again, like you said, like mass doesn't matter, but that's like the main thing that matters.
No, I'm not saying mass doesn't matter. I'm saying they could all be the same mass. They could all be different masses. 2 of them could be the same. Well, 1 of them could be slightly different. It doesn't matter. If you have 3 gravitational objects going, this happens, right? This doesn't look like our solar system.
I understand. I really do. But I'm trying to say that mass is the main determining factor in orbital.
Go ahead. I'm just saying, look what happened. The whole thing just goes away.
Okay,
we had planetary alignments this year. Like, how
yes,
come?
I saw them. I was out there looking at them.
And so how come they didn't nudge things?
I'm trying to explain.
Go.
It's so the more mass there is, that is going to affect. If you have more or less mass, is going to affect how different celestial objects interact with each other. So if
where'd you learn that?
Well, this is math stuff. I mean, I could explain the math with.
No, that's what I mean. I mean, how did you learn? I mean, where did you learn this?
Where did you learn? Explain how the 3-body problem is solved in our solar system.
Mass.
That's
it's
a word.
It's the main determining factor
Physics also?
Yes.
Math and physics. It's explained. Math and physics. 2 words.
Yes, I think we can all agree that math and physics are pretty rigorous.
I can. Can you tell me the math and physics that show how the 3-body problem resolves itself in our solar system?
Here, I'll show you some example. Oh,
you can't show us anything.
Okay. Well, maybe I could take off my thing. How do I do that?
I don't know.
I know how.
Yeah, but just hit blur background and take the background picture off. Should be fine.
There you go.
That should work.
There we go. So here's a little bit of how this stuff works. Okay, this is how we describe curvature of space-time. Okay, so the more mass an object has, you guys have seen the diagrams, the more it warps the space-time around it. Okay. So this is
so wait, you're a believer in the bending of space-time and not gravitational. You're a Newtonian, Einsteinian gravitational model, not Newtonian. When did you switch?
Well, first of all, they're not two separate things. One sort of supplemented the other and helped it progress the other one. They're an addition to each other.
So yeah, an enhanced lie. Yeah, you're right.
So just a quick question on the bending of space-time. Why does it bend it? Why does it bend it in one direction?
Mathematical concepts a lie. Okay, because math, there's no agenda or
if it's based off a lie, the math is bullshit.
Let me ask you a question. Here's some simple math for you. Simple math for you.
Okay.
You have $1 million in the bank, and I'm going to double it every day for 3 days. Tomorrow you have $2 million, and how much do you have the next day?
4
million.
Talking about
so you
growth?
have $4 million in the bank. Math proves it. Math proves it that you have $4 million in the bank in 2 days from now. Okay.
Can I see the evidence of that?
Yeah. The problem is you have bad data going into it. Okay. They figured out the distance of the sun because one day Venus, which is about the same size as Earth, transited the sun. And someone on the East Coast and the West Coast saw it start and stop at different times. And they did some really good math to figure out the sun was 93 million miles away. The problem is, got some bad data. They said Venus is the same size as Earth. I think Venus is about the size of one of those yoga balls. Okay.
Okay, but I'm trying to yes, I believe in Einsteinian theory of general relativity. I think it's our best understanding so far. I think it can still get better. It can always get better. And just because something has an issue doesn't mean that the things what it explains and predicts is incorrect. Okay, so I answered this problem of the 3-body problem. The answer to that
you answered it was math and physics.
No.
And then you showed me a bunch of scribble on a paper of equations, but you didn't explain how it works.
I can explain how it works. The more mass, let's do the trampoline example because I'm sure you guys have seen that with general relativity,
right?
Examples. You put the bowling ball in the middle of the trampoline.
And why does the trampoline go down and not up or sideways?
Okay. Oh, this is where you need to start thinking above 2 dimensions because that
3 dimensions.
Example,
I'll go to 4 dimensions if you want. Why does the trampoline go down? Why does it go in one direction and not this way or that way or that way or that way?
Okay. Let me. And that answer is due to gravity, but that's because of the inertial.
But wouldn't the gravity pull that trampoline it would create like a web around it because it would have bending trampolines at every possible angle?
Yep.
Here, let me show you what it ought to look like. That's why it's not. That's why it's not the best example. I'm trying to find this GIF that. Here we go. Let me see if I could share this. This is how that's why that dramatization of it isn't quite the most helpful thing. So this is actually kind of what it should be looking like right here on the right. You see that motion, how it's sort of it's pulling everything around it into it. Okay, so that's more of an accurate representation of what this massive thing that
one body. Now throw another body in there and what happens?
Okay, and I'm going to try and explain this. What you're looking at is one mass, okay, and it's bending space-time a certain amount. So if you have another body with a smaller mass, it's going to bend it a lot less than this one. So it's going to end up orbiting that mass. And then if you have larger masses, this one is going to orbit that other mass. Okay.
What happens if one of them gets near the other one in its gravitational range?
Then it will most likely start orbiting it, or it could just fall directly into it.
You didn't. Did you watch my 3-body problem? The problem is it would go into chaos mode and it would never repeat itself. Absolutely, never repeat itself.
It's never been proven.
The problem is with the example that you showed is that it was showing same masses. Again, the big
no. Okay,
mass.
so let's look at our solar system. Okay. We have, and we're going to get into that. We have our sun, a giant sun, gas ball in a vacuum. Fascinating, okay? And it's holding on to Venus and Mercury and Earth and Mars and Jupiter and Saturn. It's holding on to them at these incredible distances, which are cosmologically tiny distances. But it's holding on to them. And then the Earth and all the other planets are holding on to their moons. Okay. Okay. How is it when the moon comes, like say the sun is over there, the moon comes around the Earth? How come the sun doesn't rip it away or speed it up a little bit? And when it comes around away from the sun, how come the sun's gravity ignores moons but holds on to planets?
Sure. So it's not necessarily ignoring the mass of the moons. It's just, and I'm sure you guys have had this answer before, but it's because the mass of the body that the moon is orbiting, in this case the Earth, if we're talking about our moon, is so much closer to. Well, so are you guys aware of the formula for like an orbit of the gravitational pull on two bodies? You guys know what that equation is?
I do not know how Santa built his sleigh, bro. I don't. Okay, know. I'll be honest.
The equation, this is why math is important, because it helps you understand how this works, right? So the equation is the force of gravity equals the gravitational constant. I won't get into how we got that because it's a little more complicated, but and then you have the first mass,
physics
and the
second mass. Physics and
sure, physics and math. You have the first mass, let's say it's the Earth, and the second mass, let's say it's the moon, and then divided by the radius squared. Okay.
The radius. So, how did you go? Hold on. How'd you get the radius of the Earth?
Okay, the radius. No.
How'd you get the radius of the Earth?
No, that's a valid question.
We don't know. Oh, by the way, if you don't know the radius of the Earth, we don't know the distances or sizes of any of the planets. How did you get the radius of the Earth?
Hold on, because the radius isn't describing the radius of the Earth; it's describing the distance between those two objects. So if you have the Earth here and the moon,
well, how do you know the distance between the two objects if you don't know the radius of the Earth?
Oh, okay. That's a totally separate question. I'm trying to just.
But that question needs to be answered before you can figure out the distances to anywhere else. You need to know the radius of the Earth.
So actually, to find out the gravitational force between two objects, you don't need to know the radius, because you could have like a gas cloud and then like a super dense like.
So hold on, a gas cloud in a vacuum. Can you show me that in a lab or in nature?
No. Well,
Can you show me gas in a vacuum?
All right,
gas adjacent to a vacuum. Wait, hold on a second. The Earth is a rock and all sorts of stuff. And then on the outside of that Earth is water. And on the outside of that water is air. And on the outside of that air is a void that we call the vacuum of space. Show me in an experiment anywhere in nature or in a lab where you could have high pressure adjacent to no pressure without a physical container.
Okay. Dave, I gotta say, man, I'm trying to be as respectful, and I've listened to every single one of your questions, and I'm trying to address each one, but as I start answering,
all right,
you go to like,
well,
so I'm really trying my best here.
No problem. Thank you. And I'm just saying some of the questions you're asking, that's why I'm asking the question that will lead to your question. But go ahead. Answer any ones you want.
Okay, going back to how gravity works in a Newtonian sense. Okay, Newton is the one who came up with how two masses are sort of pulled to each other. Okay, whether you believe Newton or not, okay, the math it predicts exactly what we see. So you have one mass, you have a second mass, Earth, Moon. It doesn't matter what radius they are, because they could have different densities, right? The moon could be less dense than the Earth or whatever. Okay, I know, I've seen that before. But let's just talk about what they said. All right, let's talk about the math of what they said, because in the beginning of this, I said we can all agree on mathematics because it's not biased. It's just
it's mathematics based on reality. So.
Sure, and this would be based on.
When you're ready, I have a question about the gravitational constant. When you're ready, finish what you're saying, and then I'll ask.
Okay, so you have two masses. It doesn't matter their radius. It just matters how much mass they have, and then you find how distant they are from each other, and you can calculate the force between them. The force of gravity in between these two objects. That force is going to be stronger the closer that you get them to each other, right? So then you have the sun that's way far out here. And so back to the trampoline example, I know it's a dimension too small, but you have the sun, big bowling ball in the center of the trampoline. Then you have like the Earth maybe further out in the trampoline that's making its tiny little indentation with the moon inside of that indentation, right? So it's still along the bend of the trampoline caused by the sun, but it's just staying around the little hole around the Earth, right? As the Earth is staying around the big hole around the sun. Okay. So that's why the moon, to answer that question, that's why the moons of planets, because they're closer to that little hole of the planets, stay closer to their planets, and they're not getting all pulled away from the planets.
How'd you figure that out, Joel?
So that's with that. Well, that formula is the quickest way. That's the easiest.
No, I'm
way.
saying, like, how did you figure all that out?
Well,
for yourself, like, how did you come up with that conclusion for yourself? Like, what did you have to do? Did you just read something, or how did you come up with this?
Well, school first.
Oh,
so somebody told you.
Again, no, okay.
Was it in a textbook?
Hey, Joel, did Christopher Columbus discover America, in your opinion? Because school said that.
No, he did
not.
Okay.
I just wanted to know your opinion on school. But okay.
Okay.
And how old were you when they taught you this stuff?
Okay, hold on, because I don't agree with a lot of the things that school teaches. I don't even like the school system, so we probably agree there.
Good start there.
I went to the Air Force Academy. I've had quite the experience with education. I went to 3 different colleges, and I don't have my degree, so I've done a lot of my own independent research. This isn't stuff that I was just brainwashed to believe. I've done the math myself. And you can do the math yourself.
Again, you can do math, but you're based on things that other people are telling you that are unmeasurable. Question: the gravitational constant.
But they are measurable.
Well, no, they're not. Measurable. You're talking about the gravitational constant.
Really? Can you show us how to measure it?
Yeah.
Can we do it together?
But hold on. Let me ask this question.
Yeah, we could do that.
So, Joel,
I'm all right.
The gravitational constant is whatever it is. And do you know about the electrostatic force of the Earth? The Earth has a negative charge to it. The air, the sky, has a positive charge. And that electrostatic attraction of the Earth, which we say doesn't move, is a measurable, testable, repeatable force. Okay? They tell us that electrostatic force, I forget the number, it's 10 to the something power. Okay? Well, I think it's
negative
10 to like
power or positive power?
It's positive. Like it's like multi-thousands of times stronger than the gravitational force. Well, what I'm talking about can be measured, can be demonstrated. My question is, let's pretend gravity's real. How do you differentiate what's making something go down? Okay, how do you differentiate, that it's not the electrostatic force that's making something go down? Here's a little experiment we did. We got helium balloons. They're holding this wire in the air. There's a button on the end, and it's just neutrally buoyant off the ground. This wire goes to a Van der Graaf generator, and we're going to crank a negative charge into that pin. And when we crank a negative charge into it, it goes down. Positive charge. Positive charge. Ground is negative. Okay? Positive charge, It gets heavier. Did gravity just increase, or did the electrostatic pull of the Earth just increase? Okay? And then when we discharge it, it goes back up. Right? And now we can do the opposite. We can put a negative charge into something, and even though it rises up off the Earth, when we put a negative charge into it, it stays in it because we're still charging it, and it goes up. Is it defying gravity, or is it defying an electrostatic force?
Yes. It's doing both.
It's doing both.
Yes. The answer, you answered the question in the question. So it's the electrostatic force is overcoming the force of gravity in that instance.
But my question is, things go down because of buoyancy and density. Down is down because, in my opinion, because of the electrostatic force. The electrostatic force is magnitudes more stronger than the theory of gravity, which needs 90+% dark matter and dark energy to make it work.
It doesn't exist,
to make the math work. They'd have to make it up. Normally in science, when you come up with a theory, if it doesn't work, you don't make up crap to make it work. You throw the theory out and you start over. But the electrostatic force is testable. Okay? Let's pretend gravity's real, and that's really pretending. How do you differentiate the electrostatic charge effect when I could show you that when I change the electrostatic nature of something, it does the opposite?
Okay. Well, I guess there's a couple things there. First,
There are.
yeah, okay. The first thing is gravity is described as a force, but it's not really like in the sense of like I have this my levitating light moon lamp here, right? And it's like just moving above, there's nothing under it. It's just floating and
Magnetism.
spinning. Yeah,
Right.
magnetism. Okay. So that's an actual force that we can measure and
The
use.
only two forces that can be measured are magnetism and electricity. The electric
Electricity.
Okay.
force and the magnetic force. The
So
gravitational force is made up.
what happened? Okay, well, you're not completely wrong. Okay, so what gravity is like the like a centrifugal acceleration, right? It feels like there's a force, but there's actually not. It's just a result of the motion. Okay, so what gravity is a result of the curvature. So it's not an actual force in the sense of like magnetism or like you pushing on something. It's not
Joel, the gravity was created just to protect the ball theory, because without it, I mean, can you have the ball? Are we going to be, is Australia upside down right now without gravity? They'd fall off, right? So yeah, the gravity, they had to come up with something. That's their false god. That is what they preach. And that is what has led most people to this state of mind of indoctrination.
well, okay.
Because I
Well,
look, man, when you were little, they could have told you that it was, magical fairy tale rainbows that held the ball in place. And, in kindergarten or first grade, you just would have accepted it. And we all know we can't verify these stories. And that's why they had to teach you that at that age, because you have no concept of what they're talking about in any
so,
sense of the fashion. So these are made up things. So again, and I don't want to disrespect you, but when I'm talking to people about stuff like this, and you're so far this way, it's like it's like talking to someone about the tooth fairy is real or not real. Like that's how I feel, and I don't want to come off that way.
no,
But
no, I don't think you are.
okay,
I'd like an opportunity to have this stuff because a lot of this stuff can be explained. Um,
You
and
yeah,
say
from
that.
listen, it could be explained based off of what you read that from the people that don't give a shit about you or me or Dave. So you're representing people that are not in your best interest to represent, man. These are
You,
not good people that have
you're
come up with this
right.
thing.
but
So
the explanations are something that you can do yourself, I guess is my point.
But you,
really,
can
okay.
you
So you'd
show
be the
us?
first person.
Please
Yeah,
show us one because
show us proof
I have
of Earth moving. I just want, let's start there. Can we get a science test going to prove the Earth's moving?
Uh,
Because it's never been done. I mean, you'd be a Nobel Prize winning. I mean, you'd be all over the place. You'd have your own Netflix special, brother. If you came up with you'd be the first person to do that.
Are you familiar with the
So
Georgia Guidestones?
yes, I am.
All right, and you know they were knocked down, right?
I did. Yeah, I
Yeah,
saw that.
but you know about the hole in the Georgia Guidestones?
Yes, yeah, I did.
So that hole lines up with Polaris, and it's been up
Uh-huh.
for over 40 years. And the story is, even though we're traveling 4.5 billion miles a year, Polaris is so far away that there's no parallax. That's ridiculous, but let's go with it. But we're also processing. We had our North Star changes, it was 2,000 years ago. It was Steuben or whatever. And well, it would have moved at the rate of precession more than a half a degree, and it would knock it way out of that hole. A half a degree would be way out of that hole, and it wasn't. It never moved out of that hole. Now, I find it quite a coincidence that at the time where this absolutely proves that we're not moving, it gets knocked down. Okay?
Okay. Well, let's go back. Let's go back to what we
Math,
were talking about before.
physics, science, right here.
Not exactly. I mean, if you can tell me mathematically how this stuff doesn't make sense,
Joe,
Okay.
it's a
what I'm trying
perfect
to-
clock, brother. Look
Yeah.
at this. It's a perfect clock in the
We're,
sky.
we're
How is
moving,
that-
we're corkscrewing through space in 4 different directions at once, but Polaris never moves from that hole. I'd like you to tell me the math that explains how it never moves from that hole.
So
Yeah.
so the first thing is scale, right? So again, you there's these big vast distances that we're talking about. So when we what's the you guys know what the
You
formula
mean
for
the distances where we've proven that we can't see Polaris? Okay, go ahead. So now we're
Okay.
dealing with a fictitious distance that we could not see Polaris. The brightness and the size is hundreds of millions of times beyond what we could see. And so now that's going to be your proof
But
why
Dave,
it
this
stays
is
in
what
there.
they taught us, so it
I
has to be
know.
true. They taught it to us. It has to
Right.
give us. It's got to be
The,
real.
the science and the physics say that we can't see Polaris. So why are we even arguing about how we see
They
it through this hole?
okay, because you haven't shown how the magnitude of the brightness wouldn't be seen by us. Okay.
Do you
And
agree
every
that
time
every
I
time
start,
you half the distance to a light,
David,
it's 4 times as bright? Let me ask you that. Do you believe in the inverse square law of light?
yes.
Okay, so if we went halfway, it would be the. All right, I can't even talk. The brightness is something that's not even imaginable, right? The moon would be 60 some odd times brighter than the sun at 100 miles away, right? Then we see the sun. You've never seen anything brighter than the sun. If I said the better than the sun twice as bright, you'd probably melt. 60 times as
right.
bright. That's how bright it would have to be at 100 miles away from the moon, right?
Okay.
Short circuit,
Well,
and you stop thinking about it. Not you, everybody.
No, that's what happens is people memorize these equations. They memorize them, regurgitate them, get a B. Now they want an A, and they're it's like it becomes. Listen though, it becomes concrete in your veins at that point. Yeah, my bad. I barely spoke, man. But it becomes concrete in your vein because of the regurgitation and the testing and the studying of garbage. Anyone could come up with any story, any theory, anything, back it up with math because you're creating the formulas and you're creating the answers based off of bullshit. So what you do, Joel, is you read all this stuff and you're all, and I'm not judging, but you're all involved in the space stuff and it's so cool and everything. Me and Dave used to be like that, man. Like I used to be like that. It's cool. Like, you know what I mean? Like we're different now, but we understand where you're coming from, but you don't understand that you've been programmed. And once you can understand you've been programmed and you can start unprogramming little things from your head and looking at it from a different perspective. So you look at what we're talking about in your own, your same perspective of what you were brainwashed to believe. You don't see it with our eyes. We've seen it with your eyes where you're coming from. We've been there.
Joel, let me add one more thing. You cannot
understand it from our eyes. That's what sucks.
Let me add one more thing. Joel, so you're talking about scale. I know where you're going, and we've heard this argument before. But the pyramids have the Great Pyramid of Giza has a shaft that points at Polaris. And the official story, and I'm curious if you buy this, is that when they built it, it was pointing at the North Star Thuban back then, 2,000 years ago, whenever it was built. And we've wobbled to the point where now it happens to line up with Polaris. That's the official story. Do you buy into that?
Well, I'm going to say I don't know enough about the architecture of the pyramids to speak on it.
My point is when they built it, they said that they built it pointing at the North Star at that time, and then several thousand years passed, and that has moved, and now it's pointing at Polaris. So all of the time in between, nobody noticed that it wasn't pointing at anything, but now it's pointing at Polaris. But that procession would have moved Polaris out of it in our lifetime already, right? The Georgia Guidestones prove that. So what's up with that?
You said something key there. They said they built it to point at the North Star.
Yeah.
And if if the Earth does change its perihelion, I forgot what the actual term is. It's sort of like rotating like this over a large amount of time. Yeah, precession. Yes. Over a large amount of time, right? They could have still built it according to a North Star. It just wasn't the same North Star.
Right. So you do buy into the fact that we happen to live in the time where it's pointing towards another North Star. And then if you believe in that procession, how come Polaris never moved from the hole in the Georgia Guidestones? How come it never moved?
Because it would have been out of it or halfway. I mean,
it would have been way out of it. Half a degree is a lot. Is a lot.
Let me try and show you guys something, because there's something interesting here. This is our current view of Polaris. Ooh, it's kind of in the way. So there's Polaris, and there's the axial, if I move this around, this is where the Earth is rotating at the top, right? And Polaris is actually already off of the line of where the actual, the top of the Earth. If you were to stand at the top of the Earth and look straight up,
Polaris has always made a little circle. It's not the exact North Star. It makes a tiny little circle, but it stays within that hole, and it's done that all of my life.
Right, and that's because this precession precession that we're talking about takes a very, very, very long time to happen. It moves
a degree every 70 years, 70 or 2 years, whatever it is.
I'm not sure that's accurate.
That's the official story.
Yeah,
it's the official narrative. 1 degree every 72. I think it's 72 years. And that would have moved over 40 years. It would have been out of that hole.
Yeah, Polaris would not be in that hole anymore, and it was there every day. And it would have been there now. It'd be there the next 40 years. It would have been there the next 100 years. It's never going to leave where it is. So that can never be explained by you guys. It's always there. Always.
Yes, it is always there. But again, I don't think either of you are 72 years old.
So no, but a half a degree. I'm rounding down. A half a degree would knock it way out of that hole. A half a degree would knock it out of that hole. Okay?
In 40 years? Yes.
In 40 years, and that's more than a half a degree, but I'm rounding down because I'm giving the globe every benefit, every possibility it has. Can we, because we're gonna run out of time. We can go a little longer, but my question is, let's talk about curvature. Do you believe that the Earth has curvature?
I do, yeah.
Okay, so if this is the Earth and a ship or a building goes farther away, it goes behind that curvature, and zooming in doesn't bring it back because we have a physical curvature. So you agree that the Earth needs a physical curvature?
Yes.
What proof do you have? What observation do you have that shows things going over the curve of the Earth? And if I showed you that we could see things that should be far below the curve, but we could see them, what other excuse do you have other than refraction, which won't work, that we can see them? For example, let me show you one example. This is a viewing spot in Illusion, France, and we're looking out as the sun's setting, and out here is Mount Canigou, but you can't see it because it's 175 miles away. Using the Earth curve calculator, at that altitude and that distance, the very top of Mount Canigou should be over a mile or a half a mile to a mile below the curvature. I forget the exact number, but it should be far below the horizon. But our sun, our sun migrates in between the tropics, right? So if my head's the Earth, every year it passes in line with this viewing spot and it lines up. And when it does, the sun is so bright, its light can push to us, but the light bouncing off of Mount Canigou can't make it to our eyes because the air is too thick. But when the sun backlights it, all of a sudden you can see Mount Canigou in all of its glory. The very, very top of Mount Canigou right here should be a half a mile or a mile below the curvature of the Earth, but we can see it. And then with our infrared, we have a channel called J. Tolan Media, or if you check out Sean's film, the next level 2020.com.
2022.
2022.com. There's Jay Tolan is in there. He uses a infrared camera, and he can see things that would make the Earth have to be 1,000 times bigger than they tell us. And there's still problems.
At least 1,000 times bigger.
At least 1,000 times bigger. But if the Earth was 1,000 times bigger and still a globe, we'd still have a lot of problems. We still have okay, they're lying, right? They tell us there's 8 continents. Well, maybe there's 8,000 continents. Okay?
So I guess my question with that, if you're asking for an explanation, is how high is that mountain?
Well, yes, we calculate in the Earth calculator. I don't have that numbers with me, but many shows have done it. Jeranism has done it. We use, by the way, the 8 inches per mile squared is actually better than the 3 other formulas that they use because it gives the globe a little extra favor. It's actually less curvature than the more complicated formulas. And by the way, it only works up to between 500 and 1,000 miles. It gets off a little bit.
Miles.
At 1,000 miles, I think it's off by
I guess
by an insignificant amount. an insignificant amount. But the thing is, you can never see that far. You can never see that far.
Well, the thing with curvature calculation in that specific instance is you're calculating. You got your altitude, your viewing altitude.
The higher you go, the less curvature there is. We calculate the height of the observer every single time. Every single time.
Okay, and that's good. But did it take into account the top altitude of the mountain?
Of course, the top of the mountain should be a half a mile or more below the curvature. Based on that
according
altitude.
According to their globe math, a spherical math.
You love math. We say observer height, view the object we're looking at, height and distance, and it'll tell you how much curvature there is. Okay.
Okay.
And it's been destroyed over. This is
over and over.
This is one out of thousands.
Yeah. Here's one.
What is this location?
This is Canigou Mountain from Aluja, France. There's a church. That's a famous spot that people go, and you can look it up, but it'll be a little boring on this right now. But here's a shot.
Yeah.
We know how far this oil rig is. We know the camera is a foot off the ground. Well, according to globe math, a foot off of calm water should be a horizon at 1.2 miles away. Let's say it's 2 miles away. Okay. But the problem is we should have 59 feet of curvature at this rig. But not only is there no curvature, we can see the water for dozens of miles beyond it. The surface of the water is visible where there should already be 59 feet of curvature. The camera should not be able to see the surface of the water beyond less than 2 miles away. But we can see the surface of the water. And if you say refraction, the water behind the rig has to refract to the height of our eye level, and the water in front of the rig has to refract, and the rig has to refract, and it all has to line up. That's absolute craziness.
Not necessarily, because with refraction, it would get more distorted the further out it gets. So the further away that water would be, the more refracted it would get.
So it refracts up to eye level, never higher than eye level, just to eye level in front of it and behind it. How is this camera where? So if you believe in refraction at all distances, then there is no physical horizon in your world.
Not necessarily. It's not at all distances. Yes, there's a little bit of refraction, but it increases in severity the further out that you get. I'm perfectly willing to work out all of the math with all of these distances
let's do.
We hope you do. Don't believe Dave. Go do the math.
Let's do let's do the 9.4 miles between the camera and this. There's 59 feet of curvature. So work out the math. It shows me how that ever-increasing drop comes up to eye level, and then the rig comes up to eye level, and then the water beyond it also refracts higher and higher and higher. Okay? The famous shot across Lake Michigan, Chicago, you can see it 50 some odd miles away, and they say, well, it's a mirage, right? Well, a couple of our guys, Rob Skiba and Rick Hummer, got on a boat, zoomed in on it, and drove 50 miles across the lake, and it never disappeared out of their camera. Well, if it was a mirage, it would have to disappear at some point, and it never did. So we can see these distances, and it's not a mirage. It's not refracting. It's not changing. And the different conditions, change all day long there's a time lapse of the same thing for 24 hours, and the buildings never move. If it was a mirage, they'd go up and they'd go down, and they'd go all over the place. Okay.
I just want to ask Joel real quick. Do you have any proof or evidence of curvature you could share with us?
Well, I think it's just this question of scale. Again, I think it's the biggest thing, because I'm not sure how much of the skyline that you saw when you were on this lake. I'd have to go out and...
So it doesn't matter how much you see, because right here, this is a non-tidal bay, okay? And not only does the beach disappear, the buildings disappear, okay? This is an optical horizon. An optical horizon, right?
Okay.
Yeah. So our horizon is optical, and the lower you get, the less you see. The higher you get, the farther you see. And this is something that I like to show. Out here you don't see a boat out here, right? the sky meets the land, it meets the water, and then as we zoom in, we're increasing our angular size, and as we do, we can see there's a boat out there. This is an optical horizon. The boat is always there. Now watch these little waves in the foreground, which are closer than the boat, like my finger, okay, will block the boat. Will block the boat from the bottom up, and it disappears. And a glober says, oh, it's over the curve. And then you say, well, it's not. I just zoomed in on it. And they say, well, it's not that far away. We don't know how far it is. Right? That's why I showed you the oil rig. We know how far it is.
That would be an example of what I'm sure you guys call the vanishing point. Okay,
sure.
So every point of how much you can see of something in your field of view, once you increase your field of view, your vanishing point is changed. So that's what I would say explain is going on there. But I was going to say I think there's been an incorrect usage of the curvature calculation. It's not as straightforward for every point on the surface of the Earth. So I would have to get into
the curvature of the Earth changes in different areas. It's flatter in some areas.
Well, it isn't. It's not a perfect sphere.
It's an oblate spheroid. Okay,
right.
But they changed the narrative on that a few years ago. It's an oblate spheroid now. Even though NASA took perfect images of perfect spheres, no one gives a shit about that. But go ahead with your pair.
Well, you should sort of see it's the shape of it, even in the images.
You can sort of see clone copies of clouds and cartoon effects in Photoshop. I've been doing Photoshop since I was like 15 years old, 14 years old. Dude, none of those images are real. NASA will admit that. You can go to nasa.gov and look at all their cartoons, brother. Why would they give you cartoons, Joel? Why? There's not one reason to do it, man. So you go up there, you take some pictures. Me and Dave wouldn't even exist, but they've never done it, Joel, and they never can. It doesn't exist, brother. That's why they don't take real photos, videos. They don't do a 360 turn in space because it's all bullshit. Take your camera and turn around and look around and do stuff. What would you do if you were up there with full camcorders? How would you film it?
Joel, what if you and I were the first two guys to land on the moon? What would the dialogue would be? You know what it would be? Okay, kids, if you have a problem with 4-letter words, leave the room. It would be, holy fucking shit, look at the Earth. Oh my God, look, there's America. Oh my God, look at that hurricane. Holy crap. Never once did the astronauts even mention the Earth.
Nope.
They never mentioned.
There was one image they released of it. 8,000 images released of the studio set of the moon, right? Because they put a lot of money into that. Werner von Braun, they got some big boys in there. But the Earth, no, that was just to reinforce we live on a ball. They already changed the schools in the 20s and the 30s. Rockefeller, they changed everything. So they had to reinforce it. Not a lot of people were fighting it at first. They don't want to teach it in school. Teachers were getting pissed off, and teachers that were teaching in school were getting persecuted. They didn't want this crap taught. It was forced down their throats by Rockefeller and the goons, man. Joel, if you actually look at real history, you'll see this plan they came up with.
Joel, take a look out here. So we're looking out over the water, and we can see the horizon here. Now I have this is just a simulated water level. So if I said, well, the horizon's up here, well, you'd be like, no, it's right here. But then if I put this boat in here, is that boat floating in the air or is it sitting on the water? And the truth is, this is an actual photograph of a boat, right? And now if I draw the line in where I put the water level, this is just rough water here, and this is smooth water reflecting the sky. So your eyes will play tricks on you.
Sure.
And
I've seen videos with those same boats in the background. Yeah, I mean, yep.
So again, when you're looking out into the distances on stuff like this, it doesn't make any sense, right? Here's one.
Yeah, visibility is big.
Right.
Can't see that far, brother. We can't see that far.
But it's not infinite, I guess, would be my main point.
No, our eyes, we're not Superman. Right. No, you're right. No, we can't see forever.
But even with powerful instruments and stuff like
you're
that,
still cutting through trash. That's why infrared is number one with these types of tests. From the sky or from the ground, infrared is number one because you can cut through some of that shit. but you're looking at clouds upon decks of dew, dander, smoke, chemtrails, contrails, whatever you want to call them. You're looking through crap. Yeah, I like this one, Dave.
Yeah.
But
So
we
how
can't
far,
see that far.
How
Man.
far away is that sun?
I don't know what I'm looking at. I can't really see the.
Well, I mean, there's a sun there, but it's not really a sun.
So this is looking straight up at the sky, or
Sure.
is it like?
Well, you tell me.
Sure.
I can't tell. I really
Well,
can't.
so-
I thought that was just like a curtain with a light behind it.
You're right. It is a curtain with a light behind it. You nailed it. Okay. But here's the thing. Here's the thing. We don't, this is the light is 10 feet behind it. Okay. And now my girlfriend's over to the left. And I said to her, I said, where do you see the sun? Point at it. And she pointed over here. Like she sees the sun in a different position. Ready? I just
Right.
play. All right.
Yeah.
So I said, where do you see it? And she
stupid.
sees it there. I see it over
Right.
here. So I go, this
Yeah.
is her point of view.
Yeah.
And this is my point of view, right? You
Yes.
can't triangulate that. Like if we tried to triangulate where we see the sun from our, I'm 5 feet from her, and the screen that we see, well, we don't know the distance, but when it's right in front of her, we can do right angle. We can do some math that'll tell us that is 25 feet away or whatever it is. And in reality, it won't work because if I try to triangulate it where I see the sun, we're seeing the sun in two different positions. It doesn't work.
That's actually exactly how parallax is calculated. And if you did all the numbers of it, right, you found your distance between each other, and the thing is, you would have to have a reference point.
You would have to know how far or how big the object is, because if you don't know either, you don't know either.
Mm-hmm. Can't come up with an answer if you don't know either.
Right.
To begin with. Yeah. There is no answer there. It's okay to say I don't know. I mean, we say it all the time with stuff, man.
Well, no, you need a reference of something to go off of. In this case, it would be, well, I don't really want to get into that because then it gets into shadows and stuff like that. But that's how you would figure that out. Is then you would look at the light that it's and again, this through a sort of morphed, like it's going through a sheet, so it's illuminating the whole sheet all at once. So you don't really have like a solid point to go off of.
So let's just show you. I want to just show you one more thing. This is an example. This is these windmills. People say they're behind the curve, but here's an example of a boat and the sun going down. But we're just looking through a lens, like the atmosphere is a lens. And as things go away, they drop down. This boat and the sun is literally just being pulled across a flat table. But the way we see it, perspective makes it look like it goes down. It's being magnified more and more, just like you said, refraction is more and more in the distance. And that's how we see it go away. So here we are, as we pull away, these buildings are disappearing below the table that they're sitting on, right? The bottom half, the bottom 2/3 of the building are missing. They're below the table, but it's still sitting on the table. Okay. And this shows you,
and with that, as you go higher, you'd see more as well.
Right. If we lifted up the camera, we would see farther.
Yep. Just like in reality.
Yeah.
Just like all the tests everybody's doing. Yep. Correct.
Okay.
There's a difference between taking someone's word and stories and theories and the universal truth of this bullshit heliocentrism and just repeating it, agreeing. You're always going to be in agreement. You need to look at this as, you know what? Let me prove the globe to myself. Joel, that's what you need to do. Even before this flat earth stuff, some of this you might not get because you're in a different set of, mindset. But if you could try to prove the globe to yourself without I know you like the stars and stuff, all that stuff. Take that out for a few weeks. Just the Earth, the curvature, the spin of the Earth, all these things. Prove these things to yourself, no matter how long it takes. And once you find that you can't prove it, and neither can the professionals, because it's never been done, then you could start from there. But to have these beliefs and then want to talk about flat Earth, it's always going to be a disconnect, because
sure, but the thing is, like, if I were to do that myself, I'm going to be using mathematics because it's rigorous. Mathematics represent reality, right? Like
I'm talking about the scientific method, Joe. Right. I'm not talking about
but
no.
Mathematics. If we're talking about distances, if we're talking about speeds,
Joe, I agree. I agree.
Okay.
Like Aristophanes proved that the Earth, the size of the Earth, because he used his sticks and shadows. He did some really good math. Remember? You know the story of Aristophanes?
I know. Yes, I heard your point on this. I personally, if we could like not get into that, because that's another rabbit trail that I know like just gets deeper and deeper. And again,
my point is I don't care about that. I'm showing you that math is not reality. Math can describe reality, and math that can describe Narnia. I could tell you, I give you all of the architectural plans for an amusement park I have on an island that's off of off the coast of the United States. And I could show you a map of the land. I could have it plotted out. I could have all the acreage. I could have the construction, the weights, everything of the entire amusement park. It's not real. The island doesn't exist, and neither does the amusement park. So math is a description of whatever you want it to describe. So if you're going to say, I've got math that proves the shape, the radius of the Earth, show me the math.
I'd love to see it too.
Sure. Yeah. I mean, like we probably shouldn't do it now because we've gone quite long. But I would be perfectly willing to come back on. I can get, because I guess how it would go, right? It'd be like, okay, well, here's the equation for gravity. It goes off of the masses. Okay, well, how did you find out the mass? Okay, well, let's see how we find out the mass of the Earth, and then how do you find out, this, and that? So you have to obviously have starting data and starting numbers to start math, right?
Sure. But Joel, once you can admit that all the information that you already have right now in your mind about all this stuff was given to you from someone else, then you can start from there. Because none of that information, even though you're repeating it in a sense of your defense, you've done some stuff and tests and equations and like, oh, it does equal that. Oh, yeah. You're invested your emotions into something that doesn't exist. So it's hard to kind of transcribe to you what to change or how to, if you actually are open-minded, a critical thinker, then you'll find all this stuff out. But let me ask you one question, just one question.
Okay.
Did two on September 11th and the event in New York, I just want to ask you one question. That's it. Just one question. I need to know who I'm talking to here. Do you think 2 planes took down 7 buildings? I just want to know your opinion.
No, I don't.
Okay, you don't. So that's a good thing.
I think it was a demolition, controlled demolition.
Oh, for sure, 100%. But that's a good thing. So you're a critical thinker. This is a big one for you, Joel, because when you were little, maybe you believed in Santa, Tooth Fairy, maybe you didn't. I don't know how your family was, but for the sake of the argument, we'll pretend you did. All these stories, right? And obviously we laugh at them now, we're adults, but this is just the only story that you were never told wasn't true. So it's not that you're an adult and we think you're stupid for still believing in this shit. We don't, because we used to be that same smart adult that you are, right? Until we understood that they're lying about it and we started proving these things to ourselves. We got out of it. But the point I'm trying to make is once you're actually in a mindset to go, let me look into this type of stuff, you need to close your judgment of flat Earth and close your understanding of what you were taught, because you're not just defending something as an adult anymore. You're a child in your mind with this ball. This is when you were taught it, and your parents might have said, my point was, your parents might have said, hey, Santa's not real when you were 6, and maybe Tooth Fairy when you were 5, and so on and so forth, right? And you're like, what? What do you mean there's not real? All that happens with kids. No one told you the ball's not real. So you're holding on to this. Like, I just imagining you right now as a child, just holding on to the globe. You can't let it go because you don't want to. And I feel like you don't want to. And if you did want to, you would, because once you start dissecting the globe from A to Z and everything between, it's over. It's over. But you have to do it without the programming and without what we've said. None of it. Start over fresh, your brain, and start looking at the stuff as the smart man that you are now. Stop going back in time to the child fantasy and to what we're talking about. I don't even want what we're talking about involved. The Earth is nothing. Go research what they are teaching us and what they are teaching our children, and you will fucking laugh. And if you don't, I don't know what to tell you, man.
Let's just talk about one more thing, and then you can finish up. We'll let you have the final word. the closest star is 25 trillion miles away. If you were traveling at 100,000 miles an hour, which is just unfathomable, it would take you 28,000 years to get there. Okay, so when you talk about the amazingness, there's light. I'm sure you believe in extraterrestrials and stuff. Well, the extraterrestrial,
I believe the possibility. Yeah,
a possibility. Well, I believe it's 100%. Okay, but
I'm 99.99.
Yeah. I'm 100%. But like we live here, and here are extraterrestrials on the extraterra outside of us, and more out here. These are other worlds.
Yeah, that's the outer space. That's the real outer space.
That's the real outer space.
They put the truth in the words. And they know the truth.
We live here in this pond, right? And then these are other worlds just thousands of miles away.
Star Wars is real, brother. Star Wars is real.
And there might be wars. There might be stuff, territory disputes and all sorts of stuff going on. So the whole Star Wars thing works here on a physically possible flat Earth. A scientifically impossible gas ball in a vacuum is not even possible, right? You can't have a gas ball in a vacuum. So space, stop arguing about anything we see in space. It's scientifically impossible. This is scientifically possible.
Mm-hmm.
That's all.
Okay.
You get the
and
final
why do you
word.
think there's a treaty that won't let us go see what's over there? Joe, have you ever asked yourself that question? Whether or not you looked into the Antarctic Treaty or not, they will not let you, your mom, your dad, the richest person in the world without government clearance, and you ain't getting it. You ain't going to Antarctica to look around and see if there's any other worlds or any other continents. You're not going. Doesn't matter how much money you have. You can't do it. You can go to the peninsulas, the tour guided peninsulas, and go do your thing there and then go right home. You can't be like, hey man, we're going to go cruise around for the next year. It ain't going to happen because imagine what you would find. Your globe's over. There's things there that would prove the globe is done.
And here's the thing. We're not saying what the Earth is. We're saying, the Earth is
what it's
measurably, testably level and horizontal, right? Saying flat Earth, well, what does that mean? Level and horizontal, and water proves that. And we're also saying it's scientifically provably not a globe. Those are the claims that we're making. And now, are there 100%. Lands? Are there extra people and lands? I think so, but we just want the right to go explore, right? But for some reason, they say all of this land bigger than the United States, right? And I think that's just a fraction of a fraction of a fraction of what's out there, filled with resources that no human has ever set eyes upon. How come ExxonMobil isn't going, let us go out there, we'll get you 20-cent gas, right? No one's even questioning this treaty. This treaty is because if we're allowed to go outside our playpen, we discover that we're at the center of creation, that we have great power. There is no shortages. We're not overpopulated. There's no water shortage.
No. Dave, it's just to protect the penguins. It's only to protect the penguins. That's the only reason they do it.
No, you need the pristine ice also, they say.
Yeah, the pristine ice. Go look at the Amazon rainforest. Get back to me, Joe.
Take it down.
They don't give a shit.
Yeah.
They care about penguins.
And so once you understand why the lie, because they have us in a pen, they have us limiting our thoughts. Everything you have in your life is because of the way that you think, right? You create your own world. They don't want us to know how real that is, okay? Everything I have in my world, I manifested my world, and I love it because I'm thinking big. I'm thinking big, and I'm thinking for the greater good for everybody. Okay.
And speak big too. Speak it as well.
And again, I don't make crazy claims, but I know what's fake, right? NASA's faking being on the space station. Everything they're doing is a lie. Space is scientifically impossible. Let's stop talking about those lights in the sky. There is no curvature. None. Mm-hmm. Infrared. We've done the measurements. There's no curvature. It lays flat. Brother. Water at rest lays flat. We can see too far. And the whole R7/6 refraction is nonsense. We've proven it by driving across Lake Michigan and many other. They
don't care. Most people don't care. Flat Earth have done so many things, but it gets looked over because you don't want to let go of your childhood ball and this fantasy, especially when you waste, and it is a waste. Once you figure this out, you wasted all this time looking at all this stuff and believing it all. Man, that's hard. You have to at least admit, Joel, even if You don't ever have to say at this moment, especially though. Oh yeah, I believe you guys. No, don't believe us.
Yeah.
But you have to admit that is pretty true. That
right.
You were fed all this stuff as a little kid. You don't know how to talk. Why don't we fall off was probably the only question you were asked. And what is every answer they give you? Gravity, 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 gravity. Go play with your friends, gravity, gravity. Then you're done with it.
Yeah,
you're done with it. It's a universal truth at that point. It's before every movie you watch. It's placed in every TV show that you enjoy. There's a globe in someone's office, on the desk, at the house. Everything. We don't even know it. You don't even know it because it's universal.
I guess if I were to ask one more question before getting into like my closing thing, is what doesn't gravity explain?
It's a theory that needs dark matter and dark energy. It doesn't explain how the electrostatic force, how they ruled out the electrostatic force, which is testable and measurable, and multiple times more powerful than gravity. But they ignore that. They don't talk about that. Electricity and magnetism are the only measurable forces, right? And gravity is a fictional force. They even say they don't know what it is.
Right. Density and buoyancy figures everything else out. It's very simple, though.
And it doesn't explain the three-body problem. And I think there's more than 3 bodies in our solar system and in our galaxy and in the universe. Okay? It doesn't explain any of that. It doesn't explain how eclipses repeat themselves every 18 years. That's a clock.
Are stories.
That is a design.
Stories that you were told.
A high precision designed system. And by denying it, and you're a Christian, have you looked into the 200 verses in the Bible that prove the Earth is flat? Have you looked?
300.
Well, you're right. There's none that mention the globe. Right? Isaiah talks about the circle of the Earth.
That's more of a theological discussion.
But I'm with you. I never lead with it. But your book, the one that you must have some faith in, is talking about the Earth fixed in its foundation and it does not move. Yeah. Okay, but that's not a proof of the globe. I'm with you. I was a complete atheist before I found out the Earth was intelligently designed, and that made me realize there's a creator. And then your journey beyond there is your journey. I never tell people what.
Yeah, but if you want to wear your shirt with pride, you need to know what God said, and once you know,
you didn't see the rest of it.
Oh yeah, so never mind. So that's again. I mean, you shouldn't represent Christianity with that shirt.
But hold on though, because these represent these are Maxwell's field equations that actually electrostatic force is represented in.
I don't care what some Mason wrote down with his fucking pen. I'm talking about our creator. Don't compare the two again, man. Please don't do that.
All right,
I'm talking about what the creator. I'm talking about what the creator said. That's
David was referring to electrostatic force, electromagnetic force. Well, these are the equations that
I get it. I get the joke. I'm just saying, in terms of seriousness, God said, if you care about what God said, if that's not my thing, but if that's your thing, the Bibles and stuff, read it. Because it'll tell you what it is. It backs us up, and that should tell you something. That's all I'm saying.
Referring to something, a force that we can observe, and these are describing how that works.
Joel, so the electrostatic force is testably and measurable, and science, your science, with their calculations, says that it's 10 to the 15th power more, which is unimaginable, stronger than gravity. So when I drop something, rule out the electrostatic force and tell me how gravity is bringing it to the ground.
Well, I'm willing to get into the number. Not today. We could probably do it again. But I'm willing to bring the numbers on this to see. I don't know what units you're talking about. I don't know.
How would you differentiate? Maybe they're both pulling it to the ground. That's the best that you can come up with. But how do you say the electrostatic force that we can test and measure isn't, and gravity, which we made up in the dark matter, is? That's just a religion. That's a religion right there.
Okay.
Listen, we do have to go. So make your final statement. Tell us anything else. And also, before you go, I just want to say you're a good guy, and you have a lot of patience with us because we're over talking you a lot. And I appreciate your ability to have this conversation.
Yeah, sure.
Me too.
I've come in here wanting to keep it civil, keep it cool. There has, you guys have been talking a lot, which is fine.
I warned you at the beginning that we do that.
I at least wanted to have where you guys didn't feel like you were being attacked. Like I'm coming in with an open mind. That's why I'm not like constantly attacking every single thing that you guys say. I'm trying to answer it, but I guess
sometimes you just can't attack it because it's facts or reality. But I get what you mean. But you're a very civil person, and it seems like you already know about the events in New York. That's just it's always my stepping stone with people. If you think that official story is real, I don't really care.
I don't think that
all right, good. So
that's good.
You have critically thunk before, so that's good.
I do. I do it as much as I possibly can.
Trust your own senses. It's okay to trust your own sense sometimes.
Yeah, but I also trust mathematics.
Go outside and look at the sun. Go outside and look at the sun or look at the moon tonight, and you tell me how far away you think that is if you were never born into the slave system in indoctrination camp.
I guess my question:
very close.
Have you guys seen the what the heck? The moon through a telescope or through binoculars before?
Oh yeah.
The moon through a P1000.
I've used an observatory that they told. No, I had an observatory on our Copernicus science building, and they said don't point it at the moon because the moon's too bright. It's going to hurt the telescope. So that's all we did. We pointed it at the moon, and we were looking for the Apollo landing stuff, but then we gave up because we couldn't find anything. But we've looked through it, and now I was told it's 238,000 miles away. I believed it. Okay, but now I know that the moon is not. Go out when the moon's in the day sky every month for about a week. It's in the day sky, and look at it, and look at the blue sky behind it, and then go out at night when there's some scattered clouds, and look how the moon is only lighting up the clouds next to it, and not all of the clouds.
And all the rest of the clouds.
They should all be lit, but only
the
one
there, Joel. Right just there. Like God said. It's right there. And science also wanted to take that away.
And
sorry, Dave.
We showed the inverse square law. The moon is just it's not reflecting a sun. And also look at it. It doesn't have a hot spot. The whole thing is lit edge to edge, the same. And the
light up a sphere and tell me what the shadows look like.
Right. Test. All right, listen, we have to go. Our final statement by you. Because we keep interrupting you, Joel.
Facts are fun though, but go ahead, Joel.
Joel, we appreciate the conversation. Go ahead.
Okay, so the things that I'm going to look to, if you guys wanted to do this again, sure. Is the luminary magnitude of distant celestial objects. I know you guys don't believe they're distant, but if I can find the magnitude of the brightness of these things,
absolutely,
maybe I can try and explain that. Okay,
nice.
So that's great. So I'm looking at the inverse square law for that.
Don't forget the angular size too. You got to explain how we can see the angular size at those distances. As things go into distance, they get smaller. They don't stop getting smaller. Right. They always get smaller. So let's talk about the angular size of Polaris. And I'll even let you move it 100 million light years closer. 100 light years closer, sorry.
Still wouldn't work. Work.
I'll still let you move it 200 light years closer.
Come on, Joel. Can you at least admit that these distances they told us about all this stuff is hilarious? It's not?
Joel, how long?
For real? Joel, crazy.
Joel, how long?
Come on, man.
So the closest star is 25 trillion miles away. How long is 1 trillion seconds in time? And don't say a trillion seconds because that's not a fair answer. 1 trillion seconds, how long is it?
How many years is that?
It could be weeks. Don't say years.
Idea. Oh, yeah, you're right.
Do you want to take a guess? If you guess it within a month, I'll give you a Bitcoin. No math. Come on. Just do it. Just take a stab in the dark.
1 trillion seconds?
Just 1 trillion seconds.
That's going to be like years.
How many?
How many do you think? Just guess. Yeah, guess.
46 years?
Yeah, close. 31,000 years. Okay? 31,000 years is 1 trillion seconds. And they tell us Polaris is 430. I forget that. The closest star is 25 trillion miles away. These numbers, your brain hasn't been taught how to deal with it. Think of it again.
Sure.
1 trillion seconds is 31,000 years. These numbers are impossible. All of this. Nothing could be seen at 1 trillion miles away. And nothing is 1 trillion. Everything's farther than that except the sun, the moon, and our planets.
So you think that's more plausible, the story of these light year away lights, then we're saying that we don't know what those lights in the sky are, but they're very close to us. And they look like frequency energy bodies when
As
we zoom
science
in on
and math
that's
tell us.
crazy to you?
Science and math tell
That's
us
crazy.
I mean,
they have
like something
to be
like
close.
this, though. Like,
No, I'm saying though, Joe. No, I'm doing basic questions here.
Joe,
You're
this is
saying
close
that
too.
that's a crazier story that we're saying the lights in the sky that we see are just lights. We don't know what they are, but they're right there where we see them. That's where they are.
Maybe that thing you're
How's that
looking at
crazy?
is a couple hundred miles away.
Yeah.
On the firmament. Maybe it's a feature on the firmament. I don't know what it is, but you think it's 100 billion stars with a couple 100 billion planets and a couple 100 billion
Trillions
moons.
of light years away.
Trillions and trillions and trillions of miles away. And you don't even
think
understand
that way is because of
what a
it's
trillion.
only 2.5 million light years away, but
2.5 million light years. My calculation.
and it's crazy because that's our nearest galaxy too.
Oh wait,
So-
cool story. Dave? Where are they at? Where are they, Dave? Where are they? Cool story.
Cool. We both good at that.
That was the best one.
Okay, so
we
so
both
far
could have
I'm
done
gonna
it.
I'm gonna look into the
I didn't want
luminary
to
magnitude
disrespect
of
them.
Polaris.
Go ahead. Sorry,
The
Joe.
luminary magnitude of Polaris, the angular size, or however big it would look like from our view, taking into account the inverse square law of light. Let's see. What
Joel,
else
let me
was
ask you
I
a
gonna
question.
do?
This image behind you, you believe
Curvature. Sorry.
you believe that's 100 billion or whatever number of stars similar to our galaxy, maybe, right? Somewhat
This is
similar.
over a trillion stars.
Okay,
This
so
is-
a trillion
so
stars.
Andromeda's 200 trillion light years, 200,000 light years across.
Did you measure
So
that?
the Milky Way is about this big in
All right.
comparison.
So it has more stars than our galaxy. So the outer edges of that, what am I seeing? Am I seeing a bunch of stars out there? Is that what I'm
Yes.
seeing? Okay.
Yes.
Calculate the brightness of those stars at how many light years away? How many light years away?
2.5, 2.5.
2.5 million light years away. So calculate the brightness that they would have to be for us to be able to see them.
Oh, well, I could have just answered that now. When you look at this galaxy through a telescope, it's not going to look like this. You're at most going to see this this dense region in the center.
Well, calculate that brightness. 2.5 million light years away. I contend that if it was a light hour away, you couldn't see it. But listen, we do have to go. Anything else?
I was just gonna, if I can encourage at least Hibbeler, because you both, I don't think you both are stupid. Obviously, both sides think we're deceived, so it's difficult to have a discussion like this. But I encourage you yourself, just like you're encouraging me to do and I'm writing them down. I have time at work to do these things. I'm going to look at the math of this. The first thing I would say is I encourage you to look up first and try and tell me what you think it is without your knowledge and stuff. Look at the core of the Milky Way galaxy. Look at the arm. Look at it through binoculars and look at how densely packed. Because the more you zoom into it with binoculars, you can see. Okay. No. But the more you,
we both don't know what they are, Joel. I can admit that. You can't. Once you can admit you don't know what the fuck they are, then we can have a discussion. But you act like you know what they are and you don't, and you're giving the official narrative, which is hilarious. I can't wait till you see it. One day you will.
You're gonna see it one day, and then you'll be like, wow. And you have to let your ego down, and you have to realize that all of your education on this is nonsense. I did it. I took 4 years of astronomy in college. 4 fucking years of astronomy, and I was good at it. The best thing was I was so good at it that I helped all the pretty girls get their homework done, and it worked out in my favor. We'll just say that, okay? But 4 years of astronomy, it was fun, but it was all pseudoscience.
The other thing that I would say is once you can present me with mathematical models that work, that would be my big turning point.
I don't need to present you a mathematical model of work of flat Earth other than water lays flat, testably, measurably, scientifically, provably flat, okay. And the math shows that we're not on a ball. We just proved it.
No,
we already showed you the math.
I don't know the numbers, and just the same way that you're asking me to distrust the big narrative, there's even more reason for me to distrust you guys. But I'm still going to take what you guys are saying.
Right.
And try to apply it. So unless you guys have, that would be the thing that would change my mind. I guess math would change my mind. And you said if you were to set up, let's say flat Earth isn't real, okay? Just for instance, let's say it's that blueprint example of what you describe math actually is. It'll describe whatever you want it to. If you could describe the flat Earth model with mathematics that work out,
I don't have a model.
Okay, well,
why do you need a model? You know why you need a model? Because you were given a fake one in kindergarten, so you want to see ours. There ain't no model, man. Flat's not a shape. There's no model.
I couldn't purport to shift a belief in something or knowledge in something unless I see a reason to do it.
Wait. You said you distrust us more than the government and school? Okay.
Wait a minute, Joel.
You did. I'll go back. That's what you said.
Joel,
you have more of a reason to distrust me and Dave than the government.
Listen, we have playlists of videos where we've done all the math. We've done lasers across lakes, and we can see things at distances. The math proves there should be curvature, but there's none. There's the math. You're just unwilling to look at it. We have dozens and dozens of those videos. Check out Taboo Conspiracy 2 on YouTube. He has them all scientifically laid out.
I have seen.
There's your math. So don't say you need us to give you math because we gave you the math.
Not necessarily, because he was not doing it correctly, and he was. It didn't work out. He was representing it falsely, I guess. All right. Is the problem.
Listen,
it wasn't math that worked out. It was math that I don't know how to describe it.
All right, Joel.
Uncomfortable.
Joel, no, it's not that it made me uncomfortable.
We got to go.
It's just
we've been on for 2 hours. We only scheduled 1 hour, so I do have to go. So thank you for coming on. I appreciate the civil discussion. You're better than many Globers. That's not really a compliment. I think you're a good guy. I just think that you're lost in space. And I was at one time. And it's no offense. And I'm hoping that one day you see that all of the stuff you brought to us is not factual. You brought some math to us, but not really. You didn't show us how far the sun was. You didn't show us the radius of the Earth. Show us the radius of the Earth. That's the easiest one.
Show us water bend. No, show me water bending. We'll start from there.
Water at rest, bending bigger than a cup of water. Don't show us a drop of water. Show us anything bigger than a gallon of water.
Yeah, water curving. Water has to find and maintain its level. It has to be contained.
All right.
Take your bathtub away from your
Joel, I'm going to say goodbye. I'm going to hang up because I got to run.
All right, brother.
All right,
thanks.
David.
Reach out again after you look a little deeper. If you want to have another conversation, we'll talk about it. Thanks.
Okay, sounds good. Thank you.
All right, bye-bye.
Whoa. Dude, this guy is lost in space. Just lost. Nice guy, though, but man.
Nice guy, but how does somebody get that far out into Narnia?
Oh, well, like I said, it's based off of the fantasy of it all, his addiction to it, and he keeps researching the wrong sources. It's all government education bullshit. He's never gonna, he's got, like I said, he's got to start breaking down the globe for what it's not. Once he sees what it's not, then he could bypass some of these little formula things he loves so much.
He said that he loves math, but he ignores globe math that proves it wrong. He loves math, but we can see too far, and then he ignores it. It's like the programming doesn't let him see beyond what he wants to see. Yeah. It's amazing. I find it fascinating.
It's restricting his critical thought, and that's why people like him and others, it's important that we at least plant some seeds, because like I said, he woke up to 9/11 and all that. We should have asked him about COVID hoax, but the bullshit, we should have. But at least he was open-minded to knowing that 9/11 was demolition and controlled demolition. It's like, wait, the government can lie about that, but not anything like that. Again, and I get it. It's a big lie, the biggest. Takes time, but Joel, you'll get there. If you do what we ask and just look up try to find some curvature, prove the spin, and you'll be right where
high pressure next to no pressure.
That too, yeah, but right where you started when you were like, wait a minute, hold on. So if this guy really likes science and likes facts, then he's probably going to invest in getting a Nikon and doing some tests himself and proving these things to himself if he cares. Or he's going to just keep taking the word of man. It's up to him. It's really up to him. We can't force him to do anything, but scientific method will take care of it for him if he cares that much to know the truth. He'll find it, and maybe we'll have him. We'll do a part 2 down the road with him to see where what he came up with by then, because it's going to be funny to see whether I found proof of courage. I'm like, what? You're the first person ever. What do you got? And then, it'll be fisheye probably or something, but it'll be fun. It'll be fun to see what he comes up with. And hopefully he's
but how is he going to prove
real person?
The brightness of these distant stars? I mean, he believes in the inverse square law. I mean, and he believes that that galaxy is 2.5 million light years.
Light years.
Okay. Yeah. So Polaris at 2 light hours or 2 light days away, impossible to see. They tell us it's 433 light years. Well, double that. Let's call that a 1,000. That times 1,000 is 1,000,000 times. It's ridiculous how many times farther. And he believes that we could see all those little planets and the little stars around.
We didn't ask him. We didn't ask him the main question on his terrible beliefs. And that is, Joel, do you know that this is your belief, or do you think you know this? Do you know this, or do you believe it? And I would hope that he would admit that this is just something he believes, because once you can get someone to admit that out loud,
but math, that's
another stepping stone. It's like, you just believe it, right? Okay, well, this is what we know the globe cannot be, and this there's a million examples, and this is what we know about the Earth that we live on. Stationary level, facts. These are facts.
I don't know if he's capable of waking up. I don't know. He could be smart. I mean, he's got book smarts. Does he have common sense smarts?
Well, book smarts is heavy indoctrination, unfortunately.
Yeah.
But again, just the fact that he can break down 9/11, that there's something in his brain that will allow it. Yeah. Allow the critical thought, allow him to trust his senses. Because he had to have, Dave. He trusted his own senses with the controlled demolition. We all saw it. So he trusted his senses there. Why didn't he trust the scientists and the official narrative people and the professionals coming forward? And there's full-size magazines about how, that the official story was real. And why doesn't he believe any of that? But he believes the same context, the same format of where we live. The people telling us where we live in the school books. It's like, it's really weird. Usually you don't have someone act like that. But for me, at least, I know you said probably not. For me, it's possible still. I'd have to see in part 2. If we do a part 2 with him, I'd have to see where his mind is.
Amazing. So, all right.
Maybe we will. Yeah.
Thanks.
Sure.
Thanks.
All right, everybody. Thanks for joining our random show, but love you all, and we'll see you again hopefully soon. So take care.